we are given with a permutation in S8 here. We are not yet sure if this is a cycle or not, but the goal for this video is to express this given permutation as a product of disjoint cycles. Now, all permutations can be expressed as a product of disjoint cycles on the same set, even if a permutation is a cycle or not, or as is not a cycle rather. Okay, but we could use the idea of orbits in determining whether this is a cycle or not, and at the same time, the same orbits can be used to determine the cycles that we need to use as a to multiply that we could that will result to the given permutation. So let's start with the orbits. We have here the orbit containing 1, meaning where is 1 being mapped to? So 1 is mapped to 3. Okay? Then we continue. 1, sorry, not 1, because we will now proceed to 3. Pardon. Sigma of 3 is mapped to 4. Then, sigma of 4 is mapped to 7. Then, a sigma of 7 is mapped to 8. We still need to continue because the elements did not return to the first element of 1. So we have here the sigma of 8 is 6. Sigma of 6 is 5. Sigma of 5 is 2. And the sigma of 2 is 1. Surprisingly, we used all elements just by the orbit of 1. Even if you're going to use orbit of 2, you will just return to the same. Therefore, the first orbit that we could use, and by the way, the only orbit here is the orbit containing 1, 3, 4. We have 7, 8, 6, 5, 2, no, until 2, because we will not be repeating 1, 2. In this specific order, of course, on orbit is a set, so you can rearrange all of them. But basically, we can just accept this as this is, because this includes all elements. And it will be very important for us to really look into the pattern or the order of our elements, because as we look into the cycle, idea of cycle later on, we'll be using the appropriate pattern or order of the elements. Now, since we don't have other elements, is this permutation a cycle or not? Now, the proper definition of a permutation that is a cycle, it is a cycle if it has at most, meaning when you say at most, the maximum, at most 1 orbit containing more than 1 element. We have 1 orbit here, exactly 1 orbit, and it contains more than 1 element, as it contains all elements of our elements that we have used here. So, does this fit the idea of cycle? The answer is yes. This is a cycle. Okay? This permutation is a given cycle. Now, if we would like to, of course, that's another concern, but the goal here is to express this as a product of disjoint cycles. Now, since we already have this orbit here, and we are sure that this is a cycle, we can express this permutation itself as a cycle using the same pattern there. 1, 3, 4, 7, 8, 6, 5, and 2. This is the expression of a cycle that represents the given permutation. And this is already the standalone result of this given video, as this is the only cycle that we can use to solve for the given permutation. Now, let's have some contradiction. What if you would like to add another cycle, or what if there is another cycle that can be used to be multiplied with the cycle that will still result to the permutation? Now take note, the point here is disjoint cycles. If we would like to look at other cycles, let's say 2 and 1. Now, these 2 cycles now have common elements, so they are not considered disjoint cycles, right? So there can be no other cycles that can be multiplied to this given cycle with order of 8 that will result to the given permutation, because the said cycle already is an expression of the permutation. Okay, so for this given example, this is already the result. By the way, this is already the result. Now, if you would like to really to check that, of course, you could come up with a permutation 1, 2, 3, 4, 5, 6, 7, 8. And let's see if this standalone cycle, that of course it's already a cycle, the permutation is given us is already a cycle, but let's just try to check whether we will return to the given permutation. So 1 is mapped to 3, 2 is mapped to 1, 3 is mapped to 4, 4 is mapped to 7, 5 is mapped to 2, 6 is mapped to 5, 7 is mapped to 8, and 8 is mapped to 6. Do we have the same result here? 3, 1, 4, 7, 2, 5, 8, and 6. The answer is yes. That means this is already the result. So you have here 1, 3, 4, 7, 8, 6, 5, and 2. This is already the cycle that represents a given permutation. If you would really like to see a product of this cycles, not necessarily disjoint, but the product of cycles that will result to the given permutation, we will proceed to the idea of transpositions, as transpositions are cycles of order or length of 2. You will have it separate video, but just for this video alone, thank you very much for watching.